This video will focus on the square root parent graph. As you can see, you have y equals just the square root of x. This is very similar to, but different than, the sleeping parabola parent graph, which looks like the same. You have the square root, but you would have the positive and negative sitting there. So do be cognizant of what you have, whether it's just one square root or two of them. Because when there's just one of them, you create a graph that looks like this, whereas just half of that sleeping parabola, and we call that the square root graph. The locator point is still called the vertex, even though it's only half of it, and that's going to be at the point HK. As you take some time to look at this particular graph, you can shift it right, and you can shift it left, and you can shift it down, and then you can shift it up as well, right? And by doing so, you would change the values of H and K. You can shift A up, or stretch A up, I should say, and you can stretch it, compress it down, and then you can also make it negative, and it's still only going to be 1/2 of that parabola. So your graphing form is going to be y equals a times that square root of x minus h, where the x minus h is all underneath the square root, and then outside of it is the plus k. The a value, as we've seen in our others, as you move 1 unit right of your hk, your locator point, whatever distance you move up is equal to that a value. So if we take a look at our a, h, and k values here, you can see that a is equal to 1, because this is a distance of 1 for that particular problem. Now this domain is a little more unique because, as you can see, it should be considered restricted. You do not move anywhere to the left of this h value. And so that's why our domain is always going to be is that x is greater than or equal to h. So wherever the h is, that is going to be the beginning of your domain. Now some students struggle with the fact that it's or equal to, but remember, for instance, if I were to drag this a little bit to the right and have h equal to 2, now that is going to be where our graph begins. That's the vertex. So if I plug 2 into x here, and then you have 2 as your h, you can do the square root of 0. Square root of 0 is 0, so that's okay. What you cannot do is the square root of a negative value, right? So and end up with a real number. So if you plug in any x values back here, 0 or -2, -4, whatever, doesn't matter. If you were to plug that in here along with an h value of 2, you would get a negative, and you cannot do the square root of a negative. Thus, that's how you can always tell if you have a square root function what your domain would be based on the fact that you have to do the square root of 0 or bigger. Now the range is based on that as well, because you have half of this sleeping parabola, so your range is going to be y is greater than or equal to k if a is greater than 0. If a is less than 0, well then your sleeping parabola would kind of flip around, and y would be less than or equal to k instead. So I will do that on this graph. I'll take that a value and I'll stretch it down to be -2, and so you can see that our range starts at this k value and is everything negative. Now the line of symmetry, there isn't one here for this particular graph, and there is also not an asymptote. So do be cognizant of what's happening with this graph as you shift it around, and what that graph looks like. Now the Moodle syntax also here, so as you say y equals, a will be out front, you just need to use that square root symbol, and then you need the parentheses around x minus h, whatever's underneath that square root when you're typing the stuff into Moodle, and then you put a plus k afterwards. Right, so you don't need a parenthesis with the a, you put the square root symbol, but you do need the parentheses around x minus h because all of that is underneath the square root.